Hello, welcome to Digital Urim. In the previous video, we learned about package management, updates, and patching in Linux. We saw that a system that works is not always a secure system. It may be online, it may respond correctly, it may show no visible errors. But if it is outdated, exposed, or unsupported, it represents risk. Today, we are taking another important step. Now we are going to answer a key question for any analyst. Who is connected to the system? Because in cybersecurity, it is not enough to know what software is installed or whether the system is updated. You also need to know who has an active session, where they connected from, when they logged in, how long they have been active, which terminal they are using, what activity they appear to be performing, whether that session is normal or suspicious. In this lesson, we will study connected users, sessions, and basic activity in Linux. A session represents an active or recorded interaction between a user and the system. For example, a user may log in locally to the machine. They may also connect remotely through SSH, or they may run commands from a terminal. From a cybersecurity perspective, this is very important because a session can represent legitimate activity, but it can also represent unauthorized access, a compromised account, lateral movement, misuse of privileges, after-hours activity, suspicious remote access, active presence inside the system. That is why a basic analyst question is, who is inside the system right now? And then, where did that connection come from? One of the simplest commands to view connected users is who. This command can show information such as username, terminal used, login date and time, connection source, if applicable. An example may look like this: Reynaldo, PTS/0, 2026-07-13, 920, 192.168.56.10. Here we can interpret several things. Reynaldo is the connected user. PTS/0 indicates a pseudo-terminal. This commonly appears when the user is connected through SSH, using a graphical terminal, or using tools like tmux or screen. So PTS/0 or PTS/1 does not automatically mean attack, but it does tell us that the session is using a pseudo-terminal. Now compare that with something like admin TTY1 2026-07-13-215. TTY1 or TTY2 usually represents a local or virtual console. On a physical server, it may mean someone is interacting from the server console. On a cloud server, an interactive TTY session may be more unusual and should be validated. It may be a provider console, it may be a serial console, it may be a legitimate administrative action, but it may also be a signal that deserves review. As an analyst, you do not only see a line. You ask questions. Do I recognize this user? Do I recognize this IP address? Is it normal for this user to be connected now? Is the session coming from an expected network? Is it a pseudo-terminal or a local console? Are there multiple sessions from the same user? Another very useful command is W. The W command shows connected users and additional activity information. It can show connected user, terminal, source IP or host, login time, idle time, system load, current process or command associated with the session. This is useful because it does not only tell you who is connected, it may also give you an idea of what they are doing. For example, if you see a user with a session active for hours, but with a lot of idle time, that may be normal. But if you see a session at 3 a.m. running administrative commands, that may require investigation. Again, context matters. One command does not give you the whole answer, but it gives you clues. There is also a simpler command, users. This command shows the names of users currently connected. For example, Reynaldo, admin. It is a quick view, but it gives less detail than who or W. From an analyst perspective, users can be useful for a quick check, but for investigation, you usually need more context. That is why who and w are usually more useful. An important technical detail: commands like who and w rely on current session accounting records. In Linux, this information often comes from session accounting aisles, such as utmp. You do not need to memorize this right now, but you should understand the idea. These commands do not guess who is connected. They read records that the system keeps about active sessions. So far, we looked at users currently connected, but an analyst also needs to review previous logins. For that, we can use last. The last command shows a session history based on system records. It can show user, terminal, source IP or host, login date and time, logout date and time, session duration. An example may show SSH sessions, system reboots, and past activity. This matters because an attacker may not still be connected when you review the system. They may have logged in, executed commands, and logged out. That is why history matters. But here is an important forensic detail. Last does not read a plain text file like the logs we saw in the previous video. Last reads a special binary system file, commonly /var/log/wtmp. This file stores login and logout history. As an analyst, you should know that some advanced attackers may try to delete, clear, or manipulate session traces to hide activity. So if the history is empty, incomplete, or does not match other logs, that can also be a signal. To display IP addresses more clearly, you can also use last-i, and in some cases, last-a. The idea is to understand where users connected from and when the activity occurred. We can also review failed login attempts with sudo lastb. We use sudo here because records of failed login attempts often require elevated permissions. Lastb shows information related to failed login attempts, but just like with last, there is an important detail here. Lastb does not read a plain -text log either. It usually reads a binary file called /var/log/btmp. This file records failed login attempts. This can help detect brute force attempts, non-existent users, repeated failed access, suspicious activity from an IP address, attempts outside normal hours. But there is another important detail. On some systems, lastb may show nothing if the corresponding file does not exist, if no records are available, or if the system does not store those events in the same way. As an analyst, you should not memorize only the command. You should understand the intention. Search for evidence of failed authentication attempts. And if lastb does not show enough information, you can go back to the logs we saw in the previous video, such as grep-i failed password /var/log/auth.log. Or on Red Hat systems, grep-i failed /var/log/secure. The key is to compare sources. If lastb shows failed attempts but authentication logs show nothing, or the opposite happens, that deserves review. On modern systems with systemd, we can also use loginctl to list active sessions, loginctl list-sessions. This command can show session ID, user, seat, tty. To view details for a specific session, you can use loginctl show-session ID. For example, loginctl show-session 3. This can show more detailed information about the session. From a security perspective, loginctl helps understand how systemd is recording user sessions. It may not always be the first command you use as a beginner, but it is important to know because it appears on modern systems. Here is an important difference. Not every user that exists in Linux is a person connected to the system. Some users are system accounts. For example, root, www-data, sshd, mysql, jinx, daemon. These accounts may exist to run services or specific processes. That does not mean a person logged in with that account. That is why you must differentiate. Connected user, a person or active session interacting with the system. System user, an account used by the system or by services. Service account, an account designed to run specific processes with limited permissions. This difference prevents interpretation errors. For example, if you see a process running as www-data, that may be normal on a web server. But if you see an interactive login session as www-data, that may require immediate review. The analyst question is, should this account have an interactive session? A session may be suspicious if you see unknown users connected, connections from unexpected IP addresses, active sessions outside normal hours, multiple sessions from the same user in different places, direct root login, sessions from unexpected countries or networks, service accounts with interactive sessions, administrative activity without justification, unexpected TTY consoles on remote or cloud servers. But be careful. You should not automatically assume everything is an attack. The analyst's job is to validate. A session from an unknown IP may be suspicious, but it could also be a corporate VPN, an administrative jump host, a provider console, or a legitimate undocumented network. That is why the correct process is observe, compare with what is expected, review logs, confirm context, document, escalate if necessary. Imagine this scenario. An analyst reviews a Linux server after receiving an alert about unusual activity. They run who and see an active session for the user admin from an IP address they do not recognize. Then they run w and observe that the session is active and running commands. Next, they review history with lastb and find that the same IP logged in several times during the night. Then they review failed attempts, sudo lastb, and find multiple failures before a successful login. Now the story begins to take shape. We do not have a final conclusion, but we do have a suspicious sequence. First, multiple failed attempts. Then, a successful login. After that, an active session. And finally, administrative activity. The analyst must ask, does that IP belong to the company? Was the admin user supposed to connect at that time? Were there many failed attempts before the successful login? Does the account have elevated privileges? What commands were executed afterward? Is there activity in sudo logs? Do the wtmp or btmp files look complete? Should the account or IP be temporarily blocked? This is the type of thinking that turns simple commands into real analysis. A common mistake is reviewing only who is connected right now, but that is not enough. If the attacker already logged out, who will not show them? That is why you need to combine who for current sessions, w for current activity, last for session history, sudo lastb for failed attempts, and logs such as grep-i sudo /var/log/auth.log for elevated privilege activity. Real analysis does not depend on one command. It depends on connecting multiple sources. And here is another common mistake: believing that if last or lastb shows nothing, then nothing happened. That is not always true. There may be no records. The system may not be storing them as expected. They may have been rotated. Or, in a more serious scenario, someone may have tried to clear traces. That is why you always compare current sessions, history, failed attempts, authentication logs, sudo logs, and business context. When reviewing users and sessions, think in questions. Who is connected now? Where did they connect from? What time did they log in? How long have they been active? What are they doing? Is it PTS or TTY? Should that account be connected? Is the IP address expected? Were there failed attempts before? Was there sudo usage afterward? Does the activity match normal working hours? Does the session history match the logs? Should this be documented or escalated? These questions are essential for Society Level 1, because many investigations start with something simple: a connected user, a strange IP address, an unusual time, an unexpected pseudo-terminal, or a session that should not be there. Today you learned how to review connected users, sessions, and basic activity in Linux. We covered why sessions matter in cybersecurity, how to use who, how to interpret PTS, how to interpret PTY, how to use W, how to use users, how to review history with last. What /var/log/wtmp is, how to review failed attempts with sudo lastb. What /var/log/btmp is, how to use loginctl. The difference between connected users, system users, and service accounts. Suspicious signals in sessions. How to connect sessions with logs and system activity. Remember, a session is not just a connection. A session can be a clue. It can show who entered, from where, when, and possibly what they were doing. But as an analyst, you should never depend on one clue. You must connect sessions, history, logs, users, privileges, and context. In the next video, we will study network services in Linux, ports, processes, and exposure. You will learn how to identify which services are listening on the network, which ports are open, and why this is fundamental to understanding a Linux system's attack surface. Understand, defend yourself, grow.